Welcome back, everyone. Now we're going to get into LAN switching concepts. All right. So no lab here. Just let's absorb the information. So how do switches learn layer 2 addresses? Switches learn MAC addresses, burned-in addresses, hardware addresses. Right. That's the MAC address. They learn source addresses, meaning when you ping someone, it has to go through a switch. So the switch sees that frame coming up and it says, oh, look, this is a source frame. Let me put this and map it to a port that it's plugged into. Now, I have no clue where the other one is at. So it's going to flood all the other ports using the ARP protocol to say, hey, who's the owner of this MAC address? Somebody's going to respond, right? And then it'll see that source address and say, oh, okay, I'm going to take that source address and map it to this port. And then next time you ping, there's no need for ARP. All right? That's how switches learn MAC addresses, and they create the MAC address table or the CAM table, which you go inside the switch and you do a show MAC address table, show MAC address table, show MAC address table. There's a reason why I said it 3 times. 3 times. And you get to see which MAC address is mapped to which port. Now, after that, there's no more ARP, but there's still broadcast. Because remember, all of us are part of VLAN 1 by default. So we're part of one huge broadcast domain, depending on how big your switch is, of course, or how many devices you have plugged into that particular switch. So that's how they learn. Now, the next topic that I want you to understand, and I hope you understood that, okay? So you can take a look at your own network. Avoiding loops using spanning tree. Yes. Spanning tree is a protocol that by default is on. It's already working. It's up and running. Every time you plug something in, spanning tree looks at the port and says, is this connected to an end device? Is this connected to an inter-networking device? What is it doing? Because spanning tree really doesn't come alive and starts doing its election process, which we'll be discussing later on, all right, until it finds redundancy, meaning there's multiple links it can travel through. So then it runs an election, but we'll get into that, okay? But for right now, know that spanning tree, okay, is the tool is inside every switch that runs, okay, and it is used to prevent switching loops, because the nature of a switch is to continuously keep forwarding and forwarding and forwarding that frame. Something has to make it stop forwarding that frame. If not, we create something called a broadcast storm. Okay? So that's the whole concept of spanning tree. Now, spanning tree, there's different versions of it. All right, you have the plain Jane, all right, which is the old D standard, okay, which your packet tracer actually runs PVST. PVST, it still has slow convergence, and we consider slow 30 to 60 seconds. All right, and it only has one instance of spanning tree. Now, when I say convergence, I mean this: when you plug it in, and you'll see it on the packet tracer. I'll plug one in just so you can see it. The light first turns amber. After it goes amber, then it goes green. That means that port is considered a designated port, and we'll get into that a little bit later. Okay, but that's spanning tree, so it takes about 30 to 60 seconds. So we want to upgrade that to rapid PVST. Now we have a little bit, not too much, faster convergence, and we have multiple instances of spanning tree. So if for whatever reason you want to create a different instance for a particular VLAN of spanning tree, you can. And you have a little bit faster convergence than the PVST. Now, when you have rapid PVST plus, well, that's the best of both worlds. Now you have a very speedy convergence, almost immediate convergence, all right? And you have multiple instances as well. So those are your versions of spanning tree. Now, normally they say not to mess with it. Let it do its job. There's a mathematical thing that you can do to calculate But in this next presentation, I'm going to show you how span tree creates the election and all that. Normally, your core switch, and again, I'm getting ahead of myself, but it's the main switch and everything goes off that main switch. All right, so you want that core switch that's going to that core router, or that router may be connected to another router, but that's going to the router, that's going to be your root bridge. And we'll talk about those terms in a little bit, okay? So that's what span tree is, and these are the different versions. And I'll show you how to convert to rapid PVST, okay? Which gives you that faster convergence. You don't have to run the plain Jane version of it, all right? And it'll help you, but we'll be running one instance of span tree, and that's not a big deal. And I'll show you how that works, all right? So this is it. So now we know how switches learn source addresses. We know the tool that's involved to avoid switching loops at layer 2, okay? And the different versions of that particular tool that will help us avoid switching loops. I'll see you in the next.